Hello guys, welcome to my YouTube channel. Today we'll be starting a new topic called calculus and we'll be dealing with differentiation. In this topic, we'll talk about the rules of differentiation, the various methods used in differentiation. This is going to be an introductory class and then we'll move on to intermediate level and then higher level calculus. So make sure you subscribe to this channel so you'll be notified whenever I upload videos. So here are the rules of differentiation. So here the first rule says if y equals c, where c is a constant, then dy dx is 0, which can be written as y equals cx raised to the power 0. This simply means differentiating a constant gives you 0. So let's illustrate this. Let's say y is equals to 3 and we ask to find dy dx. So if we differentiate dy dx, this will be equals to 0. Since there is no x here, a constant, which can be any number, is equals to 0. So let's see, the second rule says if y equals nx, where n is a constant, then dy dx is equals n. So let's illustrate this. N is a constant. Let's say y, the constant, is 4, and then x. If we differentiate this with y with respect to x, this becomes dy dx. Here, the power here is 1. It's not going to be there, but we take it as 1. It's 1. 1 times 4 is 4. And then x, right? 1. Your 1 is subtracted by 1. So this becomes 1 times 4 is 4. X raised to the power 0. So our dy dx here is equals to 4. So this is our dy dx value, which is 4. So always subtract the power by -1. So let's look at the third rule, which says if y equals x raised to the power n, y equals x raised to the power n, and this is what it gives us. If we illustrate this n comes down, y will be equals to n times x, and then you subtract n, which is the power by 1. So if you illustrate this, let's say y equals to x squared. So differentiating y with respect to x, we have dy dx. This becomes 2 times x, and then 2 you subtract by 1. 2 here is our n. You multiply 2 down, and then you subtract by 1 from the rules. So dy dx, 2 times x is 2x, and then 2 minus 1 is 1, 2x. So these are the dy dx value, which is 2x. So now let's talk about the fourth rule, which is a general rule for differentiation. A general rule here. So we say if y equals to a raised to the power xn, where a is a constant, then dy dx equals this. Illustrating this, let's try to do something. The power here is n you multiply down, becomes n times ax, and then n is subtracted by 1. If we illustrate, this becomes, let's say, 5x squared. Here our n is 5, our n is 2, sorry, our a is 5, and we have x. So we apply the rule, dy dx is equal to 2, which is our n, multiplied by 5, 2 times 5, x, and then 2 subtract by 1. So here our dy dx will be equals to 10x. So this is the rule. This is the general rule for differentiation. This is what we're going to be using to solve most of our questions here in calculus. So let's start by solving questions relating to these rules. We'll start with the first example. The first example here says we are asked to find dy dx if y equals to 4 root of x, 4 all root of x. So here we write y is equal to 4, and then you know this is square root, so whenever you have square root means half. So we're going to write x will be equal to raised to the power half. So we have here 4x raised to the power half. So we now differentiate with respect to x. This becomes dy dx is equals to half this power, which is n, multiplied down, half multiplied by 4x, and then this half we subtract by the power 1, or subtract by 1, sorry. So here we have 2 here cancels itself and cancels for 2 times. So we have dy dx is equal to, now this is 2 times x, 2x, 2x, and then we'll find the LCM here. Half subtract by minus 1 gives you LCM there is 2, 2, 1, 2 into itself, 1 times 1 is 1, 1 into 2 is 2, 2 times 2 is 2 times 1 is 2, 1 minus 2. So we have here now, this is equal to 2x raised to the power minus half. So dy dx is equals to, from the rules, write 2, this becomes 2x raised to the power half. You can leave it this way, or you can say 2 upon root of x. So that's it for the dy dx. So we're going to solve other examples. Please make sure you go through the other videos. And guys, please don't forget to like, share, and subscribe to this channel if you find this work useful. So let's continue from our last example. So we have 2 questions here to solve. We have this, we have to find dy dx if y equals to 5x raised to the power 4. So let's solve this. So we first of all write this x raised to the power 4 goes up, it becomes negative power. So let's say y is now equals to now 5x raised to the power minus 4. From the laws of indices, we differentiate this becomes dy dx is equals to minus 4, this power, multiplied by 5, x, and then minus 4 is subtracted by power minus 1. So we have here minus 20x, 4 times 5, 20, x, and then minus 4, minus 1 is minus 5. So we have here dy dx, and the loss of indices again, minus 20, you write your minus 20, and then you can bring x raised to the power 5 down for you to get rid of the negative sign. So yeah, this is our dy dx value. So this is the answer for this question. So let's move on to the other question, which is this: y equals to 6 cube root of x. So we write y is equals to 6, and then we write x. Cube root means 1/3. We write 1/3 here. So here we're going to differentiate again. Dy dx, differentiate with respect to x. This is, we can write this as y equals to 6x now raised to the power 1/3. Differentiating this is dy dx is equal to 1/3, which is our n value, comes down multiplied by 6. 1/3 multiplied by 6, and then we have x. 1/3 is subtracted by the power minus 1. So we now have 3 cancels this, 3 into 6 is 2 times, so it's 2x now left. Rest of this, so we find the LCM here. 1/3 minus 1, find the LCM, so we write dy dx is equals to 2x. 2x now, this is 3, the LCM here is 3. So 3 to itself 1, 1 times 1 1, minus 1 into 3 is 3, 3 times 1 is 3. So we now have this as dy dx is equal to 2x raised to the power 1 minus 3 is minus 2 over 3. So rewriting this becomes 2 all upon x raised to the power 2 over 3. So this dy dx, this is our answer, 2x squared 2 over 3. So this is our answer. So don't forget to like this video, share, comment, and then subscribe to support the work I do. So we'll move on to another example in our next video. Thank you.